Welcome to qnawire.
In problem 8, we have some data on the amount of sodium in milligrams in one serving for a random sample of 3 kinds of foods. And these foods are condiments, cereals, and desserts. And we're going to find out using analysis of variance if there's a significant uh, difference in the mean sodium amounts among the 3 kinds of foods. And we're going to be using the level of significance 0.05. So first things first, we're going to state the null hypothesis in part A. Then we shall proceed to give the critical value of f and then to work out the calculated value of f. So the null hypothesis in this case will be mu1 equals mu2 equals mu3, because we have 3 different means, the means for condiments, cereals, and desserts. Then the alternative hypothesis will be at least one mean is different from the rest. Now, before we get the critical value of f, we have to know the degrees of freedom for the numerator and the denominator, and also the level of significance. In our case, the level of significance alpha is 0.05, and for the numerator degrees of freedom, we need k minus 1. K is the number of groups in this study, and since we have 3 different types of foods, then k will be 3. So 3 minus 1 gives us 2 degrees of freedom for the numerator. For the denominator, we need n minus k degrees of freedom. So we need to know n, which is the total sample size, and we can do so by adding all the sample sizes for the individual groups. So for the first group, the condiments, we have a total of 7, sample size of 7. Cereals have a sample size of 7. Desserts have a sample size of 8. And that gives us a total of 22. So n is 22 and k is 3. So 22 minus 3 gives us 19. So we'll be finding the critical value of f when the numerator degrees of freedom are 2, the denominator degrees of freedom are 19, and the level of significance is 0.05. And that gives us the value 3.52. Next, we're going to find the variance. In part C, we're going to find the variance between the groups, and this is the formula that we need to use. And for us to use this formula, we'll need to give, we need to have the n, the sample sizes for each group, which are already present. Then we need to get x bar I, which are the sample, the means for each group. So when you work this out in your calculator, you'll find that the mean for condiments, x bar 1, is 165.71. For cereals, it is 245.71. For desserts, it is 237.5. Also, from working it out on the calculator, you'll find that the variances for condiments is, the variance for condiments is 5,695.24. For cereals, it is 3,928.57. For desserts, it's 7,335.71. And so when you substitute the values into this equation, then you will have your variance for between the groups. Also, we need the mean, the grand mean for the whole data, and the grand mean is gotten by adding all the salt amounts for all the three types of foods and then dividing by the sample size of 22, and that gives us 217.2727. Now we can substitute the values into this equation so that we find out the value of the variance between the groups. So for condiments, we have to get a sample size of 7. The mean for condiments is 165.71. Then you subtract the grand mean, 217.27. Then you square that. That should be added to the sample size for cereals, which is 7, in brackets, the mean for cereals, which is 245.71, minus the mean, which is the grand mean, which is 217.27 squared. And finally, we add that to the sample size of desserts, which is 8, multiplied by the mean, which is 237.5, minus the grand mean, which is 217.27. Then you square that, and all this should be divided by k minus 1, which is 3 minus 1. And when you work this out, you will get the variance between the groups as 27,543.51. Next, we can work out the variance within the groups using the given formula. And here, we have to substitute the values that we see from the first part of the question, and this means we need to have n minus 1, this first sample size minus 1, that's condiment 7 minus 1, that's 6, multiplied by the variance for condiments, which is 5,695.24. We add that to the second group, which is cereals, 7 minus 1, that's 6 again, times 3,928.57. Then we also add that to 8 minus 1, which is 7, times 7,335.71. Then all this will be divided by the sum of n minus 1, and that is 6 plus 6 plus 7. And when this is worked out, the value for the variance within the groups is given by 109,092.86. For MSB, the mean square, for the mean square for between the groups, we're going to have the value 27,543.51 divided by the degrees of freedom for the numerator, which is 2, and that gives us the value 13,771.75. For MSW, the mean square for the variances within the groups will be given by 109,092.86 divided by the degrees of freedom for the denominator, which in this case is 19. And when you work that out, you get 5,741.73. Next, when you work out the value of f from these two values that we've gotten for MSB and MSW, then you will find that the f equals 2.399. Now we need to compare the critical value and the calculated value of f. And from the diagram we see, you can make the critical value diagram here. This is the f distribution. The critical value of f is 3.52, and thus the area to the right is the critical region. And in our case, we have gotten the calculated value of f as 2.399. So in this case, we have to make a decision to fail to reject the null hypothesis, because the calculated value of f is not within the critical region. And failure to reject the null hypothesis means that there is not enough evidence to support the claim that at least one mean is different from the rest. So then it means that the salt amounts, the salt amounts for each kind of food are not significantly different from each other at the 0.05 level of significance.